Good morning, everyone. Welcome to the GISS Sea Level Rise seminar. Today, we're very glad to have Dr. Shaina Sadai. She is currently the HITS Fellow for Litigation Relevant Science at the Union of Concerned Scientists. And her research interests include sea level rise, ice sheet dynamics, future climate projections, and climate justice. Dr. Sadai's 2-year fellowship is focused on exploring climate attribution of sea level rise and global methane emissions. And she is particularly interested in how international law can be applied to the changes sea level rise will bring. Prior to joining UCS, Dr. Sadai earned her PhD from UMass Amherst in the Department of Earth, Geographic, and Climate Sciences, where she studied changes in climate and sea level resulting from Antarctic ice sheet instability and the climate justice implications of the modeling results. Dr. Sadai also holds a MS in applied mathematics, a BS in astronomy and astrophysics, and a BS in physics from UMass Amherst. And she will be speaking today on the topic investigating Antarctic ice sheet climate feedbacks and climate justice implications. Welcome, Shaina.
Thanks so much. I'm going to share the screen and wait for the little Zoom window to move so I can click the presentation button. Can everyone hear me okay? There we go. Okay, yeah, thanks so much everyone for coming. I did just start my postdoc at UCS in September, and today the presentation is almost entirely about work that I did for my dissertation when I was at UMass. And so to start off, let me minimize this a little bit so I can see myself, see my slides. Okay, there we go. So yeah, to start off, we're thinking about Antarctica. This is like my dissertation work all revolved around Antarctica and the Antarctic ice sheet, and particularly what changes Antarctic melt could cause to future global climate, which I'll get to in a second. But just to motivate part of this, we tend to think about Antarctica because of the sea level rise impacts, but it also has impacts on broader climate dynamics as well. And so when we think of Antarctica, we're generally talking about it in sort of like two halves, with the West Antarctic ice sheet holding about 5 meters of sea level rise potential, and the East Antarctica holding much more, about 52 meters of sea level rise potential. And it's fringed by floating ice shelves, which help provide that buttressing support that holds back the grounded ice further in. Let's see, are my arrows to go forward working? No. Okay, there we go. So Antarctica is vulnerable, of course, to melting under those floating ice shelves, which then causes the thinning and loss of buttressing, which can then lead to sea level rise impacts when grounded ice is lost. And so with the ocean, the warming, given that the ocean is taking up about 90% of the accumulated heat in the Earth system, this can cause a lot of vulnerability. And so this is just what a look at what the bedrock underneath the ice sheet looks like. And then this is some observations from recent years showing places where the ice is thinning out and where we're starting to get some acceleration seaward. And then thinking about sea level rise, of course, this is a huge societal concern because it has a very long-term and irreversible impact, and that'll end up affecting island and coastal communities around the world. And sea level rise has been accelerating over time as, of course, emissions have increased, and it's also very unevenly distributed. So this is some satellite altimetry data just showing sea level trends over the observational period from 1992 to 2022. And then this is from IPCC Assessment Report 6, just looking at some projections under emission scenarios 2.6 and RCP 8.5, showing that looking into the future, sea level rise is projected to increase over time, even under a low emission scenario, though of course impacts would be much worse under a high emission scenario. And Antarctica, particularly if instability thresholds are breached, could become the dominant contributor over the long term. And so the melt from Antarctica doesn't just impact sea level rise, it also impacts global climate, but climate models that are used to inform future projections in CMIP-5 and CMIP-6, they lack fully dynamic ice sheets, though this will soon change because there are so many teams doing incredible work to try to get fully interactive ice sheets into global climate models. But thus far in CMIP-5 and CMIP-6, modeling projections tend to underestimate the impact that melting ice will have on the global climate. And so to correct for this, teams do freshwater forcing studies, and these have been done for many, many, many years. And work by a lot of different groups shows pretty consistent responses, which is an expansion of sea ice, a delay in the globally averaged surface air temperature rise, and increases in subsurface ocean temperatures. And so, of course, the delayed air temperature rise could potentially delay surface melting over the ice sheet, but the increased subsurface ocean temperatures could potentially increase basal melting. And so we have a lot of different mechanisms and feedbacks within the Earth system that would impact ice sheet stability, and these are not super well constrained within the current generation of models. And so when I was starting out with my PhD research, my first chapter was one of these freshwater forcing studies. And to do that work, I was using the community Earth system model, which is able to simultaneously simulate the atmosphere, ocean, sea ice, and land, running at about a 1 degree grid. And I was also using the Penn State University ice sheet model, which is able to simulate basal melt, calving, surface melt, grounding line migration, and importantly, marine ice sheet and marine ice cliff instability, run at about a 10-kilometer resolution. But in my first chapter, when I was doing this freshwater forcing study, I wasn't running the ice sheet model. I was using output from my advisors, Rob DeCanto and Dave Pollard, from their 2016 study. And I was using the output and the meltwater from that study to force CESM, and then doing the freshwater forcing that way from existing results. And this is just to personalize it a bit. This is like how I actually do my work. I don't do field work. I do these simulations on supercomputers, but I like to say that I do field work and that it's just climate modeling field work. So I take my computer outside and I hang out in my garden and I like to watch the wildlife around me and feel motivated by our beautiful Earth and wanting to study it and wanting to help advance climate action. So this is kind of what my day-to-day work day kind of looks like, which is really nice. And so in that first study, and this was published in 2020 in Science Advances, we were using that output from PSU model to force CESM, and so calculating mass loss rates, and then what the freshwater forcing would be, interpolating that onto the CESM grid, and putting that in a spatially and temporally varying manner. So the input is going into the CESM ocean at the closest ocean grid cell to where the mass loss actually occurred within PSU, and then this is some of the resulting surface air temperature fields under RCP 8.5. And so as you can see, this is the anomaly between the freshwater forcing experiment and the control experiment. And it does have that delayed surface air temperature rise, and particularly over the Southern Ocean, but it impacts the global mean. And so that really motivated me to try to dig into what that all means in terms of climate justice. And that's what the majority of this talk will be about today. But I also want to mention, just while we're talking about climate feedbacks, that Yue Dong led a really incredible study that just came out in December 2020 in GRL, which is really looking at the mechanisms behind this negative feedback that Antarctic melt induces on global mean surface temperature. And so she was finding that Antarctic melt causes both local and remote changes, and that when you include Antarctic meltwater, simulations are able to better resemble observational record, and that the meltwater reduces the projected warming rate via both changes in ocean heat uptake efficiency and radiative feedbacks. This is a really incredible study. She did some really great work here, so I encourage you all to check that out if you're interested in the mechanisms behind the GMT negative feedback. Okay, so turning to the climate justice section, and I have a chat, so let me see if I can open this. Cool. Yes, turning to the climate justice work, when I was starting to do the analysis and write up the paper with my freshwater forcing results, I was just like really going through my head, like what this negative feedback means in terms of climate impacts and international climate policy. And so particularly because of the Paris Agreement temperature goal. So the United Nations Framework Convention on Climate Change was established in 1992, and this is the international effort to try to come together to do something about the pressing issue of climate change. And so within the UNFCCC in Article 2, it contains this statement, which is that the goal of Article 2 and the UNFCCC is to stabilize greenhouse gas concentrations in the atmosphere at a level that would prevent dangerous anthropogenic interference with the climate system. But there isn't really a particular way to operationalize that within the UNFCCC itself, other than this phrase of stabilization of greenhouse gas concentrations. And so the parties to the Framework Convention come together every year in the Conference of the Parties to figure out sort of how to operationalize this. And after literally decades of negotiations, the Paris Agreement was developed in 2015, which states within it a goal of holding the increase in the globally average temperature to well below 2 degrees Celsius and to pursue efforts to limit the temperature increase to 1.5 degrees Celsius above pre-industrial warming. And so this kind of guides international policy around climate action. And so to me, I was thinking about this in terms of the dual impacts that Antarctic melt has. It is, of course, contributing to sea level rise, but then also there's this negative feedback that a lot of different models are showing on the GMT rise. And so I was wondering what the climate justice implications of that are in light of the Paris Agreement temperature target. And this is just like sort of a motivational figure that's in the paper that I'm going to talk about next. So this is the negative feedback on air temperature between the freshwater forcing experiment and the control experiment in that 2020 study. And then we used that the outcome of that CESM simulation to then force the ice sheet model with that freshwater perturbed climate projection. And this is the sea level rise response. So like relatively small up to 2100, but then increasing out into the future. And so just thinking about these two things simultaneously made me wonder about the connection between science, policy, and justice. And so for the rest of my dissertation, or a large chunk of it that came after the Science Advances paper, I was really digging into this question starting from about 2019. That's when I started talking about this preliminarily at conferences and doing the research and writing the paper. And so I worked on this from about 2019 until 2021 when I submitted it and put the preprint online. And then this actually did get published last year. It came out in Earth's Future in last November. And so the guiding questions of this paper, Paris Agreement and Climate Justice and Equitable Impacts of Sea Level Rise Associated with Temperature Targets, the guiding questions behind it were, how did the long-term global goal within the Paris Agreement come to be based around a global mean surface temperature metric, which is hereafter called the LTTG, or the long-term temperature goal? And then what are the climate justice implications of this, particularly when we're considering sea level rise, and how do projections of Antarctic melt interface with temperature targets and justice considerations? And so the paper is sort of broken down into 4 sections. The first 3 focusing on different aspects of climate justice, which are in terms of sea level rise and the temperature target, and those would hold even in absence of things having to do with the Antarctic Ice Sheet. And then there's a case study about the Antarctic Ice Sheet that comes after the 3 justice sections of the paper. And so this work, my primary dissertation advisor for this chapter was Dr. Regine Spector, who is a political scientist and brings such incredible depth of knowledge about global geopolitics and political power dynamics to my dissertation committee. She's an incredible person. And then Dr. DeCanto and Dr. Natalia Gomez also joined in on this paper and helped with advising, and particularly around the section on the Antarctic case study. And so thinking about how's the freshwater at the surface? Yes, this was surface freshwater forcing, but there's a study by Andrew Pauling that shows that within CESM, the response when the freshwater is input at the base versus at the surface did not make a huge difference within the CESM response. So yes, that does matter in general, but there is work published that it doesn't make too much of a difference within CESM. Thanks for the question. And so just to kind of motivate this, global efforts are of course not on track to meet the temperature thresholds that were set within it. So we're currently at about 1.2 degrees of warming. And of course, we're very rapidly approaching 1.5 degrees Celsius of warming, and current policies put us on track for close to 3 degrees of warming. And so let's see. The long-term temperature goal is considered in reference to 2100, and so that's how policy is kind of framed, as thinking about 2100. But sea level rise evolves over centuries, and the 2100, while it's not directly mentioned in the Paris Agreement, is connected through Article 4, which talks about balancing sources and sinks by the end of the century. And then the conversation about risk tends to skew towards this conversation around global mean temperature. So it skews towards a single environmental stressor and just one globally average value, when climate impacts are quite variable by location. And then what is considered, quote, dangerous anthropogenic interference. I mean, arguably dangerous anthropogenic interference is already happening. And a target of well below 2 degrees Celsius is pretty vague, and it also obscures the role of emissions. So these ambiguities within the UNFCCC and the Paris Agreement have sort of served to enable a delay in emissions reductions. And we'll look at the emissions over time since the UNFCCC was established in a little bit later in the talk. And so one thing that we argue in the paper is that it's crucial to understand this LTTG origin within the context of the broader inequalities that characterize global climate negotiations. And the disciplinary lens that we were using in this paper is that of critical physical geography. And so critical physical geography is a relatively new subfield of geography that was put forth by Rebecca Lathe. And it talks about how we can't rely on explanations grounded in just physical or just social sciences, because social biophysical landscapes are as much a product of unequal power relations, histories of colonialism, racial and gender disparities as they are of hydrology, ecology, and climate change. And then Emma Colvin and Marcus Thompson kind of explored critical physical geography and the role of climate modeling, and bringing a critical physical geography perspective to climate modeling in this paper that they wrote, that I found hugely influential as I was shaping my dissertation research. And so they're making the case in their paper for an interdisciplinary approach to climate research, and particularly climate modeling, in order to better serve the goals of social and environmental justice, to have social and natural scientists really start to engage more meaningfully with one another to produce sort of more socially relevant research. And so the methods and tools that went into this work were a really vast literature review. I searched United Nations archives, history, geography, physical sciences, politics, law. I read hundreds and hundreds of papers. There's more than 200 references within the body of this paper. And I wish I could have cited more. They're all incredible. Please check out the reference list. There's some really great research in there. And we also used sea level rise fingerprints from the PSU ice sheet model and compared ArcGIS to analyze spatial statistics around those sea level rise impacts, and then temperature and sea level rise outputs from CESM and PSU 3D simulations compared to work from other teams. And there's more and more coupling studies coming out. When I did this work years ago, there were fewer. And so I'm now thinking about the kinds of follow-up work that I'll be doing to this piece, given that there's more information now because so many teams are starting to work on coupled modeling. And so the theoretical framework that we're using to explore justice in this is the threefold framework of procedural, distributive, and recognition justices. So distributive justice is talking about equitable distribution of burdens and benefits, and this has sort of been reconceptualized within the geographic literature to think about climate impacts over space and time. But this was originally, the theory of justice was around distribution of sort of like domestic goods and things of that nature. And then recognition justice, which is about recognizing the differences in cultural and social groups and seeking to address systemic injustices and disadvantages. And then procedural justice, which is thinking about inclusion, political participation, and the role of structural power in the decision-making process. And so when I'm applying the theories of justice from the philosophical literature to sea level rise, I'm thinking about distributive justice in terms of the long-term spatially variable impact of sea level rise, power dynamics within international negotiations, particularly based around target setting, and recognition justice around recognizing the existence rights of cultural and social groups which are threatened by rising seas. And so the paper also talks about the alliance of small island states because of their geographic vulnerability that many of the AOSIS nations have to sea level rise. And this has always been very central in their negotiating positions. And they've had a very strong and ongoing history of advocacy within the UNFCCC because they were formed even before the UNFCCC was back in 1990. And they were formed basically following the first ever international conference on sea level rise, which took place in the Maldives in 1989. And this is just a map of where AOSIS nations are located in the Caribbean, Pacific Oceans, off the coast of Africa, and in the Pacific. Okay, do not become overwhelmed by the slide. I don't expect or want you to read it at all. This is just, it's one of the things that's one of the figures in the paper because we do a lot of reconstructing of history in this paper. And so we reconstruct the development of the temperature goal. We talk about the evolution of sea level rise, scientific knowledge throughout the time frame from the late 1980s to present day when this paper was submitted for peer review. And then we talk about the different positions, negotiating positions and statements that the Alliance of Small Island States was releasing during this time period. And so because there's so much historical analysis in the paper, we wanted a timeline that readers could refer to just sort of like go back and piece through what we're talking about in different sections at different times. But I just wanted to include this here so that I could have a visual reminder to myself to mention a few things about it. And one is that the use of global mean temperature wasn't inevitable within the process. It was one of many sort of different metrics put forward that global international action could be based around. And so some of these targets and indicators were suggested coming out of the 1987 Vellok and Bellagio, I'm not sure if I'm saying that correctly, workshops. Back in the late 1980s. And then the sort of like early attempts to figure out a common goal were based around binding emissions reductions, particularly for countries of the global north. But after the Kyoto Protocol, there's a lot of historical geopolitical reasons why that sort of effort at basing things around binding emissions reductions, which would tie into the UNFCCC goal of stabilizing greenhouse gas concentrations in the atmosphere, that fell out of favor following the late 90s. And that was sort of like the shift within the negotiation space towards a metric which we would base more around global mean temperature. And then thinking about like what were the IPCC reports, what sort of knowledge about sea level rise projections were contained within them at different periods, and particularly what was known about the Antarctic Ice Sheet is discussed in the section in the Antarctic case study. But I just wanted to point out that that using temperature as a metric was not inevitable within the process. It was the result of a complex international multi-decadal process that is embedded within international power dynamics. And so that's the first section of the paper, is going through the development of the temperature target and the geopolitical history of that. And then the section of the paper is about recognition justice, and it starts about habitability and migration. And this is particularly because in the negotiating statements within the UNFCCC that are released by the Alliance of Small Island States, this is a consistent theme throughout their entire history. And so they talk a lot about the threats of sea level rise, particularly around habitability and migration, and talking about the disappointment in the lack of ambition in the negotiations to protect the island states. And that they often bring up that it's on their minds that in the future, members may no longer hold seats at the United Nations if the world continues on its present course. And the reason that's brought up is because international law is unclear about what happens to the status of a nation that loses all of its territory, for instance, to permanent inundation from sea level rise. So this is something that comes up time and time again, that they stress that sea level rise is an existential threat, and also that losses and damages from rising seas are already being experienced. And so there's also scientific knowledge showing, or scientific research showing when these sort of impacts of permanent inundation or diminished habitability of low-lying island nations could start to emerge. And statements also from AOSIS tend to emphasize the preference, of course, for adaptation in place and the rejection of a narrative of inevitable climate refugee status. There's also a lot of work talking about how there's a need for nuance, for local perspectives, and for a historical grounding when talking about sea level rise and migration. So the first part of the recognition justice section focuses on this question of habitability and migration. And the second part of recognition justice focuses on the legacies of colonization. So almost all of the AOSIS nations were colonized, and the majority gained independence within the past century. And through colonization, the high traditional adaptive capacity for environmental change that was held in many of these locations, since they are situated in fairly dynamic environments, there was a traditional high adaptive capacity, but this was reduced due to resource extraction, colonial occupation, genocide, forced migration, and all of those aspects increase modern vulnerability to sea level rise. So it's highly relevant. And then there's also the issue of inclusion. So colonization was, of course, in part motivated by wealth extraction, and that fueled industrialization, and that released greenhouse gas emissions and generated gradients of wealth and power and systems of dependency. And then these systems of dependency retain influence today in negotiations, but also within the scientific process. And so there's an increased there needs to be an increased recognition and inclusion of local and indigenous perspectives in policy discussions and scientific research. And then one of the things that's cited is a carbon brief report on inclusion of authorship, because all of these things sort of grow out of the legacies of colonization. I mean, even our global network of tide gauges shows a legacy of colonization within it. And this is a newer analysis from Carbon Brief that just came out, showing that the global south is home to 84% of the world's population, but is very small in terms of IPCC contributions. And this just sort of, it influences the kind of content that comes into scientific knowledge and into the policy spaces. And so I'm going to pause for water for just a second. Okay, thanks. And then tying together the issue of recognition justice and distributive justice, recognition justice across generations will in part be determined by the spatial and temporal distribution of sea level rise. And so this is what we turn to in the third section of the paper. And so thinking about distributive justice, I'm thinking about it across time and across space. So this is a plot of global emissions. So combined emissions from all the nations in the world are in red, and then combined emissions of AOSIS nations. All of the AOSIS nations are in blue, and that's at the bottom here. So literally basically nothing. But what I'm showing here is that during the time from the start of the UNFCCC to modern times, emissions have increased over that period. So certainly no stabilization of greenhouse gas concentrations in the atmosphere has occurred. And this has come with an additional commitment to sea level rise. So there's work from Nauels et al. Showing that from the UNFCCC to the Paris Agreement, that 23 years of negotiations, the emissions during that time period came with a sea level rise commitment of an additional 0.12 meters by 2100 and 0.25 meters by 2300. So that presents an issue of intergenerational justice, because of course the impacts of these emissions will be affecting people far into the future. And near-term policy and emissions will obviously be dictating the long-term response of sea level rise. And even under a 1.5 sea world, there could potentially be 3 meters of sea level rise over 2,000 years, or 6 to 7 meters over 10,000 years, which is particularly a concern for atoll states which don't have very high elevations. Some of the maximum elevations are only around 3 meters. So that's certainly a concern. And just to put this in the larger perspective of global history in the last couple hundred years, that time period from 1990 to this figure is from 2019, but from 1990 to 2015, that's 50% of all historical emissions have occurred, CO2 emissions, since around the time of the UNFCCC. So this is a steadily increasing problem. Another aspect of distributive justice that we talk about in the paper is that of overshoot pathways. So overshoot pathways, of course, you're probably all familiar, but just a quick explanation is like when you're thinking about a 1.5 C world, there's kind of 2 ways that you can get there. You can always keep the temperature under 1.5 C by reducing emissions, or you can overshoot that 1.5 C and then return to it by 2100. And so that's how this is really being thought of in the policy space and normalized in public discourse, especially around like carbon dioxide removal, which is, you know, a fan favorite of the fossil fuel industry right now. And so these overshoot pathways, how did those come to be? We also trace the history of that within the paper, and it started around 2007. And of course, through integrated assessment modeling, which is thinking about minimizing the expense of mitigation, but climate damages aren't really included in integrated assessment models. And because they're economic models, but they do include some Earth system processes, but generally not the cost of damages incurred and not the cost of damages incurred during the overshoot period. So this normalization of overshoot pathways, there's work by Carton et al. Talking about the theory called the political economy of delay, which is saying that the normalization of overshoot pathways, this idea that we'll emit now and draw it down later, justifies delays in near-term mitigation and thus continues the sort of status quo fossil fuel-based emissions economy that we all live under. So overshoot pathways, they justify a particular target, the temperature target, as being achievable while simultaneously legitimizing the lack of action, which would render it unachievable. And that presents a bit of a problem, particularly when we think about sea level rise, because overshoot and drawdown, that may work for temperature, but that's not going to work for sea level rise. So this was a figure from a paper that Rob DeConto led in 2021 about the Paris Agreement and sea level rise from Antarctica, where we modeled what would happen if carbon dioxide removal was initiated in a particular decade. Like, what is the sea level rise response of the Antarctic ice sheet? And of course, carbon dioxide removal does not protect the ice sheet. And so this is a problem when we're relying on this in policy spaces, but it could come with additional impact burdens. And so then thinking about distributive justice, not temporally, but spatially, we're thinking about the spatial distribution of the Antarctic sea level rise fingerprint within the Antarctic case study section of the paper. And this was some data that was generously provided by Dr. Natalia Gomez and her graduate student, Jeremy Rothman. And then I remapped it and did spatial statistics to calculate the sea level rise impact under different scenarios, both different emission scenarios and also different ice sheet scenarios. So like with or without the Mickey process turned on, what would the sea level rise impact be at different time periods in the future at each of the AOSIS locations. And I also want to point out here that I mapped this in a good Homolocene projection. And I did that because there is work in the critical cartographic literature, which was seeking to understand the best way to showcase island nations on global maps, because often they're sort of relegated to the sides. And so this type of mapping projection can sort of center the ocean basins and center island nations. And so that's why we did that. And this map here is showing RCP 4.5 at the year 2100 without the Mickey process turned on, and showing the spatial distribution of sea level rise. This pink line here is the global mean, and this is areas that are experiencing less than the global mean. And so this is all from GRD effects, gravitational, rotational, and earth deformational effects that are causing this fingerprint pattern. And then above this pink line is places that'll be impacted by higher than the global mean from the Antarctic portion of the fingerprint. And so it's not just that AOSIS nations would be more heavily impacted, because certainly other places would as well. But in the paper, we're stressing that that impact is particularly disproportionate given the emissions information that I showed earlier, showing that they're contributing effectively absolutely nothing to global emissions. And so then switching to getting back to the original motivation why I started doing all of this research, which is about the feedbacks on GMT. And so freshwater forcing projections show negative feedbacks on GMT, and with uncoupled studies, which was mostly what I had to reference, pretty much entirely what I had to reference within the paper, it showed a negative feedback of about 0.3 to 1 degree Celsius by 2100, and potentially higher feedbacks in the following century under high emission scenarios. But induced climate feedbacks then influence ice sheet trajectory. And so coupled modeling is really, really key for constraining these feedbacks. And carbon budget calculations that dictate what the remaining emission space is within a particular temperature target, those don't generally include feedbacks, though there is there's motivation to include those, and Jerry Regelj has written about this quite a lot. And so one thing that we want to point out in the paper, so we don't take any policy prescriptive position within this paper. We're not saying don't use temperature, use sea level. We're not saying anything like that. We're simply trying to think through the justice impacts of using temperature when you consider sea level rise. Certainly, there will be a lot of issues with using global mean temperature post 2100 because of all of the different feedbacks that could be initiated. So it would be particularly difficult to base policy around this post 2100 because of the potential for induced feedbacks. And so to sum up this section, about temperature targets and climate justice, the justice analysis is showing within the procedural section how power dynamics influence the decision to adopt a temperature target over sort of the preferences of AOSIS and others who wanted binding emissions reductions for high emitters. The recognition justice section is exploring how losses and damages, and particularly the potential threat of permanent inundation, how that is thought of by AOSIS, and how that's represented within the social sciences and physical sciences literature, and also within the legal literature around, what is the status of a nation state that could potentially be lost. And then this is also bringing in the fact that historic oppression impacts modern impacts, and the need for inclusion and representation within all sorts of different spaces. And then the distributive justice section is looking at how GMT by 2100 doesn't fully avoid dangerous anthropogenic interference, especially given the long-term temporal and uneven spatial pattern of sea level rise. And then the Antarctic case study is showing that sea level rise coexisting with negative feedbacks on GMT can exacerbate all of the justice issues that were just spoken about within the prior 3 justice sections, and that overshooting the Paris Agreement goals, that further exacerbates all of the climate injustice concerns, because Antarctic stability points could lie around 2 degrees Celsius. And so when we have the political economy of delay sort of justifying the near-term emissions by saying, well, we'll draw it down later, that can cause increased distributive injustice over time and recognition justice across generations. And then the spatial fingerprint of Antarctic sea level rise is disproportionately affecting AOSIS nations relative to their extremely low historical emissions. And so turning to coupled modeling, the last chapter of my dissertation, I did a 2-way coupling between CESM and PSU 3D. So rather than the initial work that motivated the justice study, which was just taking the output of PSU 3D and giving it to CESM, in 2020, I worked out a way of coupling these two together so that data is exchanged every single model year. And the ice sheet model is providing that liquid and solid mass discharge at places around the continent. And then CESM is providing back the annually average subsurface ocean temperatures, monthly air temperatures, and precipitation. And so I did this work from 2020 to 2022, but we never actually submitted it for publication. We're planning to submit it probably in like a month or two. So hopefully this will eventually come out, but there are other teams that have published some coupling studies that are really cool that have come out between the time that I submitted the justice paper for publication and today. And so when I was doing this coupled study to do model validation, we were checking against observations over the observational period, and we were checking calving and basal melt rates around the ice sheet margin, basal melt rates at specific locations like Pine Island, Thwaites, Ross and Ronnie, Filchner ice shelves. We were checking the total annual change in mass and the total sea level contribution, and then the spatial patterns of ice thickness change, just to see if this coupling was actually producing anything decent over the observational period. And after a lot of effort and time, it did actually produce an ice sheet that looks pretty good. So this is my change in ice thickness from 2005 to 2017. It matches pretty well with this observed ice thickness change from Paolo et al. In 2015. And then looking at the projection side of things, this is under RCP 8.5 again. This is the projected change in ice thickness by the end of the century. And then this is the sea level rise response. We got a very interesting sea level rise response from the coupled simulation, which is that when we're looking sort of at the observational record here, the East Antarctic ice sheet is contributing negatively to sea level rise because of the increased precipitation and snowfall accumulation, whereas the West Antarctic ice sheet is contributing positively to sea level rise over the observational period. And these trends kind of hold until about mid-century. But then as we get closer to the end of the century, something interesting happens, which is that the East Antarctic contribution to sea level rise overtakes that of the West Antarctic. And that is because of surface warming over the margin of the East Antarctic ice sheet, which is inducing hydrofracturing. And there's a lot of mass loss that is coming off of that, which you can see over here. And then of course, some loss over in this region as well. And looking long term, this is going to go through a little video, and this is the multi-century response. And so that sort of trend of the East Antarctic they sort of tend to track each other, and they're kind of contributing equally to the sea level rise from Antarctica by 2200, and that's a little bit under 3 meters. And there's my ice sheet moving there. And I forgot to mention here that this projection of 0.27 meters by 2100 is pretty well in line with the AR6 range, and that it's also a negative feedback on ice sheet contribution. So when we're able to have the delayed surface air temperature rise induced by the freshwater forcing, and also that increased basal melt, it's the reduced surface temperature rise that seems to be having more of a dominant control, because we're getting lower sea level rise contribution than when we either run it uncoupled or run it where the ice sheet is just taking in the output of the freshwater perturbed simulation. So when we run the ice sheet just with the freshwater perturbed climatologies, but not in a coupled configuration, that ends up with 0.47 meters of sea level rise, whereas when we run it fully coupled, we end up with 0.27 meters. So it is delaying the sea level rise response. And then looking at the climate model temperature response, how am I doing on time? I'm okay. Climate model temperature response, we do again have the negative feedbacks on surface air temperature, and those appear by mid-century, and then they strengthen after 2100. They're less intense when comparing them to the one-way coupling. And this is a sort of a spatial look at the 30-year average of the 2-meter air temperature anomaly by the end of the century. And then this is looking at it over time, the blue line being the 30-year rolling mean. So you can kind of see this is 0, where there'd be not feedback. And then by 2100, about 0.25, and by 2200, by 2100 and by 2200, strengthening over time, so increasing feedback. And then looking at the temperature feedbacks in terms of the sea level rise, these are both within the coupled simulation. So this is the sea level rise combined from the coupled simulation, and this is the rolling mean of the GMT response. So increasing sea level rise, increasing negative feedback. This is pointing to that issue that GMT-based targets could become more problematic post 2100. And of course, it doesn't just matter what the ice sheet freshwater forcing feedback is. It matters what the combined impact of all different climate feedbacks will be on surface temperature. So like this is a pretty strong negative feedback, but then of course you have things like permafrost melt, which could be a pretty strong positive feedback. And so having the combined influence of all of those feedbacks is something that's going to be fairly tricky. So having a policy target that's based around temperature is going to become an increasingly difficult thing to use if negotiations start to think about like, what does a post 2100 target look like? Because of course we have a GMT target in the Paris Agreement now for this century, and we're not making an argument to change that. And obviously the UNFCCC, that like there's documents stating that it's not going to be changed. But when we're thinking long term, when negotiations do start to talk about what kind of metric should be used after 2100, because it's really not that far in the future, people alive today will see 2100. This is something that I think needs to be considered within negotiations, is how complicated is it going to get to use a temperature-based metric as feedbacks really start to come into play. And so looking ahead, of course, we need to keep trying to constrain these feedbacks and improve projections of sea level rise. And this really needs coupled studies to really be able to assess what feedbacks are going to look like. Obviously, I'm showing just like one set of models here. There's other teams working with other sets of models. And so, the more research we get around this, the better we'll be able to figure out what these feedbacks really mean in terms of climate response and in terms of ice sheet stability and sea level rise response. And then I'm also saying that I think that collaboration across disciplines and across geographies, collaborations around the world and across disciplines are really beneficial for thinking about the impacts of some of the things that are coming out of the physical sciences literature. So I encourage people to like read social sciences literature, talk to social scientists, and really try to see what kinds of things can be created when we start to collaborate outside of our disciplines and outside of academic spaces. And also, I think it's always important to work on efforts to make policy and research spaces more just and more inclusive. And that will help us with generating socially relevant kinds of research. I also want to point out that we had a huge win in the international space on March 29th when the United Nations General Assembly voted to adopt the resolution to request that the International Court of Justice issue an advisory opinion on climate change and human rights. This effort was initiated by law students in the Pacific Islands who formed the group Pacific Island Students Fighting Climate Change, and sort of initiated this whole call to get the ICJ to issue an advisory opinion. And then Vanuatu sort of led that charge in the international space, along with 17 other members of the core group of negotiators who drafted this resolution and then requested input from all of the nations in the UN to try to figure this out. And so when that resolution was put forth on March 29th, it was adopted. And so the ICJ has been requested to issue an advisory opinion on climate change and human rights. And this is very relevant to the things that I've spoken about today and to the things that we discuss in the paper, because international law was largely written before climate change was a thing that anyone was really thinking about. You do end up with these tricky sort of legal questions about like, what is the status of a nation that could potentially be really severely impacted by climate change to the extent that they could lose physical territory? What does sea level rise mean in terms of the definition of exclusive economic zones? What does it mean to have potential migration when just there's so many questions that this advisory opinion could shed a light on that are related to sea level rise. So I think this was a really great international win. Vanuatu and Pacific Island students fighting climate change and all of the rest of the core team of negotiators really did some incredible work to get this to happen. And this is something that I'm thinking a lot about and working on in my postdoctoral work, where I'm sort of like continuing this study about international policy, scientific research, climate justice, and the questions under international law and a changing climate and what it means to really protect human rights as climate change progresses. So thank you so much. I know this is a little bit different than a lot of the talks that usually happen in this seminar. So I appreciate the folks who showed up and listened to it today. Thanks. Next up.
Okay, thanks a lot, Shaina. That was very interesting. Do we have any questions? Anybody? Yes, Klaus, have a question.
You mentioned the solicitation by an opinion of the International Court of Justice. Does that include recognition of climate change refugees? Because right now, the only refugees that are really recognized are war-related refugees. And that is a big problem, really, when we think of future migrations that are forced.
Yeah, that's a really great question. Thank you so much for asking that. And yeah, actually, I just convened a conference session a couple of weeks ago at the American Association of Geographers, and this was one of the questions that one of the speakers was talking about, is that there is no real help for refugees that are environmental refugees. And this is one of the things that I think that they're hoping that the advisory opinion could shed light on. I'm going to put a few links in the chat for a second. I'm going to put in the paper link and then also the link to the actual text of the resolution asking the ICJ for the advisory opinion. And then also I'm going to put in an article that I wrote about how the ICJ opinion relates to sea level rise. Let me get things in there. But yes, I think that is something that people are really hoping that this could shed light on. So that is the paper. This is going to be the actual text of the resolution inviting the International Court of Justice to issue an advisory opinion on climate change and human rights. So that's Vanuatu's website. And then the other one is on
the other hand, I mean, it's nice there will be an advisory opinion if it comes about, but the United Nations in the past, when its Security Council, always the US and others vetoed any attempt. So, that advisory opinion will not necessarily change that situation unless the United Nations, including the Security Council, without a veto, adopts a regulation that climate refugees are being internationally recognized. It's a step in the right direction, but it's not the necessary step that's needed.
So a few things. Yeah, there was some concern that the US might have tried to stop the vote on this resolution from going forward, but ultimately, thankfully, they didn't. And thankfully, there was enough support. I think over 150 nations ended up supporting the resolution, so it didn't even need to go to a vote because there was so much support. But yeah, whether how it ends up getting recognized and adopted is certainly something to be seen. But I think it's really important that this is being celebrated as such a huge win by Vanuatu, by the Pacific Island youth, and by so many people around the world, especially countries that have some sort of geographic vulnerability to climate impacts, it's really being celebrated as a huge win because it'll help with sort of operationalizing the Paris Agreement, kind of trying to get the NDCs a little bit more on track than they already are, and then thinking about some of these legal questions around refugee status and other sort of things that folks are worried about under international law. So I think it is still a huge win, but yes, we certainly need to wait and see how it ends up playing out, what the actual text that the ICJ releases is going to be. It's certainly something to keep an eye on in the coming months. And I'm excited to see what they say about it.
Okay, are there any other questions? Anna.
Hi, Shaina. I'm just wondering if you'd thought about, are there any places, so the AOSIS nations are sort of right in this epicenter of sea level rise. Are there any places where sea level fall due to sort of this hemispheric fingerprint might be beneficial in some way to communities?
It's a really interesting question. I am not sure. It's hard to say. Like we're pointing to the Antarctic fingerprint in this paper in the Antarctic case study section, but of course, like there's so many factors that go into the regional sea level rise at a particular location. There's the Greenland fingerprint and all of the sort of like combined impacts of the different spatially variable aspects of sea level rise. So it is a really interesting thing to sort of think about. But I haven't thought about it too much because I keep thinking about like where the most impact will be. But it's a really interesting question. Like, are there places where sea level fall will have a big impact? Yeah, we should talk about this in our meeting tomorrow. Thank you for the question, though.
Yeah, actually, I had another question. So I was wondering about, you mentioned that paper that said that climate modelers should work with affected communities or people more. And I was wondering how that might happen and what effects that might have on the climate modeling in general.
Yeah, that's a good question. I think like how that might happen, I think one of the really important things is not to go in with like an already set up research project and go to a community after the fact and ask them to get involved, but really to go to a community before designing the research project and ask what types of things they are most interested in, and then to co-design sort of like the guiding questions and the methodologies and to really put it together as a joint effort. I think that is really a great way to try to do climate modeling studies. This is something I was talking about when I was visiting the National Center for Atmospheric Research a few weeks ago, because they're also starting to think about this co-production of climate knowledge with communities. But I think that's really the way to go when trying to design a climate modeling study that you want to have sort of like community involvement with.
Okay, well, we're at the hour, so I guess we can stop here.
Okay.
So,
Thank you.
again.
Thanks so much.